So now what we will discuss is we will discuss 3D representation, like how I can represent a point or a pixel in 3D space. So that we call it like the 3D representation. So two major families of 3D representations are there. Two major families of 3D representations are there. So that is explicit and implicit. So the idea is that if I want to represent a pixel in 3D space, I can go for a, and not only pixel, it can be scene also. Like, and what is a scene? Collection of pixel is scene. So how I can represent a scene in 3D space? So in order to represent the scene in a 3D space, I can go with explicit representation. I can go with implicit representation. So we'll discuss both of these things. So first, let us focus on explicit representation. So explicit representations, explicit 3D representations. What we do is that here we make use of direct geometric structures. So in order to represent a 3D scene in 3D space, we make use of geometric structures like 3D geometric structures, and we combine those geometric structures to represent a scene in space. So we define a shape using discrete geometric elements, and that geometric elements can be points, edges, or triangles. And in implicit representation, what we do is that instead of making use of geometric structures, we make use of continuous functions. So in implicit representations, continuous functions learned by neural networks. So we will represent a scene using a continuous function. There we will be having a continuous function. That function, whatever input you will give, it will give the output. Like you will give a coordinate as input, that okay, and it will give the output like okay, what will be the pixel in that coordinate. In that way, so I have a function, it can generate, it can represent a 3D scene. So if this is the coordinate, this is how the pixel will look like in the 3D space, like that. So that is the implicit representation in the form of a continuous function. So explicit representation, we saw that okay, direct geometric structure. So